For this project, we were divided into groups of 3 and assigned with the objective of creating and designing our own rockets.
Using the 3D modeling on Inventor, we were able to be specific about our rocket, like the diameter, the finish, and the color.
I designed a little feature inside the rocket. It's a ledge that keeps the engine from flying into the main body of the rocket.
And basically we had to make the best rocket possible that would go the highest. After we were done designing our rockets, we actually got to 3D print them and are having a design competition to see which design was the best and which rocket would go the highest.
We used math to help us find equations of the slope of the altitude of the rocket, how high it would go, and what would be the peak point of its altitude and where it might land.
Which is something really cool with engineering, that you get to design and then actually build and test your products. I find it interesting.
So my team's rocket has a pointed tip, a narrow body, and elliptical fin shapes. Everyone did get to put their input in and kind of just went with the best looking rocket.
The way my team designed our rocket that will make it perform the best is 3 tail fins, a long sleek body that is 11 inches, and
the nose cone is a parabola shape compared to most other competitors are using a pointed nose cone.
Our team had a very interesting tail fin design on our rocket. It kind of starts out thin and then it gets gradually thicker. And I think that will help with drag and wind resistance.
The nose cone, it is designed for speed. A rocket has 4 fins because I believe the 4 fins will make it go faster, and having too much fin will have less efficient.
the nose cone is pointy, and the length of the whole rocket is like not too long or too short, so that's kind of in the middle.
Having a very pointed nose cone will allow for it to go higher in altitude, and that exact shape is what engineers make for rockets that actually go off in space.
I chamfered the fins for increased aerodynamics. I also gave the thickness of my rocket a thickness of 0.045 for, to make it really light.
For our rocket design, we made the nose cone sharp so it'd have better accuracy and stability, and the size of the rocket would have a bigger impact because of how short it is.
I made the body and the nose a small size, so the whole rocket is lighter for the engine.
We made the nose cone pointed as to avoid wind resistance. We made the fin ellipses because it helps fly farther. And we made the body the maximum length.
We designed a rocket that was in the middle of the minimum and maximum height requirement. It is slim enough so that it is easier to go through the air.
We designed our nose cone pointing for aerodynamic, and we add a total of 6 fins, 3 in the upper body and 3 in the lower body. The lower body fins is longer than the tail of the rocket.
Or nose piece. Interesting design. It's based off the NASA rockets, which is it goes up, out a little bit, and into a point. Also for our fins, we have 3 different sets of fins. It might increase drag. I'm not really sure.
For our nose cone, we made it a little bit curved so it could cut through the air and have less wind resistance.
The fins particularly will help the rocket perform better because it is in a curved shape, which helps with air resistance.
Good morning, P-Tech students. I just want to let you know how proud I am of you, and I can't wait to see these rockets soar. So without further ado, let's get a countdown, and 5, 4, 3, 2, 1! There's no going back. The world keeps spinning on.
that, guys. You crushed that launch. It was amazing. A lot of great designs, and we had a lot of fun out here. Wish you guys could have been with us. But in the end, Team 3 took the prize, launching their rocket 353 feet high. Super proud of you. Max, what do you think?
Great job.
All right, awesome job, guys.
Even though there's this quarantine, we continue to learn and we've designed pretty cool rockets.